Hey, hi. Today we are solving 1200 problems. So I'm solving these, let's say, four problem or four, two, three, and this is the fourth one. So this is the first problem. Once upon a time, Mike decided to come up with an outstanding problem for some stage of ROI Ray Olympics, you know, from informatics. One of them came up with a problem prototype, but another stole the idea and proposed that the problem for the another stage of the same Olympiad. Since then, the first Mike has been waiting for them to propose the original idea for some other contest. Mike wait until this moment. You are given an array A of an integer. You are also given category of two types. Replace I element in the array with X. Replace each element in array with X. After performing uh, each each query, you have to calculate the sum of elements in the array. Okay. So if t is equal to 1, then two integers are given and position of replaced element and its value. And if t is equal to, then integer x is key flowing new value of each element in the array. Okay, so actually what we are given replace the ith element in the array with integer x and replace each element in array with x. So uh, first of all, for this problem we need to know what the operation is going to impact in our array. So पहले तो like ये a1 a2 दे रखे a1 a2 a3 a4 a5. If I am changing, if t is equal to 1 is the first operation, then it will gonna affect only one element. Okay, and in terms of sum, okay, we will gonna come on the sum later. If t is equal to, that is the second operation. In second operation, what will gonna happen? All the element will gonna change. Okay, so we don't have to worry. If t is equal to 2, 1 is 2 is there, then we don't have to worry about all the other elements, all the other operation that is apply before that. Okay, yeah, I think so. Like first of all, we are changing some index. We are applying the first operation, and then suddenly we applied when we applied second operation. That means after that all values will change, so that these operation is not considered in our answer. Will not gonna affect our answer. Okay, so what we gonna do? So we just take the look with what is the last second operation, and after that all of them we gonna change. I think so, that's it. Yeah. mm. A of I is this and query is 2 into 10 to the power 5. I think so, yeah, that's it. And okay, so what we're gonna do? First of all, I'm just making this array. A is the original array, this is the original array. Okay, and then I will look into it. If there is any second operation, if there is any second operation, then I will take the last one second operation, and I will change the value of a of all the elements, that is equal to x. That is the value that is given in the last second operation. Okay, and after that all of these operation will gonna take off one time. By changing at any particular index, it gonna take only off one time. I think so, that's it. It will gonna take off one time, and that's it. So let's code for it. So if you understand, then pause the video and do the code yourself. If don't, then follow me. Okay, then what again? We have n and q. We have t not actually. Okay, we have n and q. N and q. Then we have vector of a of n. I'm just taking the whole vector for in a of I. Then after that, I'm just taking the operation be like t is equal to 1, t is equal to 2, I x and x. Okay, so I'm gonna make it offline, you can say. Okay, that will be good. Pair of int comma int, first operation. So I'm only storing the first operation. Okay, I'm only storing the first operation and storing a bool, that is second operation present. If it is present, I make it is true as well, otherwise it will be false. If it is present, what is the value of x, what is the change element? Int change value. I'm just putting -1 for the same. So uh, we have queries. I'm just taking all the queries one by one. All the query, first I'm taking the t value, if t is equal to 1 or if t is equal to 2. Okay, if t is equal to 1, I'm just put in my this, what is that, the index and the value, that is this one. I'm just taking the index and the value. I think so, yeah. I'm just putting that this is our first operation. And when we come at the second operation, what I'm gonna do, first of all, I just clear my the array. Like I'm 100% sure that when this operation is applied, then the second operation is applied, all the first element, what is that, all the operation that is applied before this point will be nullified, because all the element will be changed. So I will be gonna clear my first, and the value will be changed. So this is the x value, that we will gonna change all the elements of the array to this x. So I'm gonna, so changed value is x, that's it. So first of all, I'm just look if second, if changed is not equal to -1, that means second operation is present. We don't need this boolean variable, because if this is changed to something else, that means we come to this block of code, that means the second operation is present. If -1, then for I into 0 to n, I'm gonna change all value to x, and a of I is equal to x. After that, what I need to do, I need to traverse over the first array, like the first operation that is after this changed value. Okay, size and I plus plus index and value. Index is equal to, what is that, first of I dot first, and value is equal to first of I dot second, like the same thing what we stored here. Okay, this is, sorry, this is changed. Yeah, here we go. So I'm gonna change, what is the index value is equal to value, and for long value, that is the result, that is the sum of all the values I need to store, and that is a of I. C of so, yeah, that's it. 5, let's, oh, it is not, why it is coming 5, by the way, it is not, should be 5. Like I'm applying first operation, second operation, then it must be 5 actually. In the second operation, I am changing, this is the last operation, and I am changing all values to 111, then it should be 5. The sum of element is 5, yeah. After what we need to do is, what is the sum after each operation? Oh, I apply something else, my bad. Okay, maybe I read the question wrong, I think so. I didn't read that I need to find the value after all the queries, for the first I queries. Okay, so what we need to do, if I need to print after each queries, so if I'm just applying first operation, that's not a problem. If before this operation we have a sum this, then the sum will be the value present at this index minus this value, some the current value we need to replace, and the value present is this value will gonna, this is the sum, changed sum, if only first operation is there. But if there is a second operation, okay, if there is a second operation, then what we need to do, then I need to change all elements to x, then sum will be n into x, that is okay. But after that I also need to apply the first operation. Then what I need to do, so if after that hmm, okay, I can do something like that. So I can say that there at most 10 to the power 5, at most 10 to the power 5 index will gonna change. Okay, so what I'm gonna do, I just creating a map, or you can say a map is good. I'm just creating a map. When I'm applying the first operation, so I'm just putting that this index having this value. Okay, if and when I'm applying the, so what is my, what I need to choose, why I need to choose the map and all these things. Okay, first you need to understand this. So I need some data structure, so that when, like, I don't I will not able to use the array, because when we are playing the second operation, then I need to traverse the whole array, then it will be complexity will be of n for each query. Then at, if there are all second operation in the query, then this is the complexity will be n square. I can't afford this. So what I need to, I will choose a map. So why map? Because when, what I gonna do, in the map I'm just storing the value of, first of all I'm just storing a value x, that means, and an empty array, empty, this one, empty map. Or you can say I'm just storing the original map, original, all the original elements. Then when the some value will come, like second operation is come, then I'm clearing the map. That means if any index I'm just, and after that there is any first operation, that means, and the value is not there in the map, so I'm gonna say that I need, then the value of that element is x. Okay, yeah, I think so that will gonna work. So what I'm gonna do, I'm just storing a map. So if I'm applying the second operation, then I'm gonna clear all the map. Okay, so now a map is empty, and I'm just putting my changed value to the value that is given in the second operation. Then let's say it is x. When I'm applying the first operation, let's say I'm applying the first operation on the index second value, I'm going to change 3. So first of all I'm searching the, if the one is present, one index is present in the map. If it is present, then it is okay, then I'm gonna take what is the value in the map, and I'm change the value to this one. If it is not, if this is not present in the map, though I'm gonna say that the value of that element will be x. Okay, yeah, that's it, that will gonna work. Okay, so I need to change, this is not required, a map, that will be int comma int m. So if it is the first way operation, or, and I also need a variable sum, that is the sum, and sum is equal to, first of all I need to initialize the map and sum. Oh, long sum is equal to 0, sum will be equal to a of I. Then this will be map, and I'm setting the map value of index I is equal to a of I, or I'm gonna say I plus 1 is equal to a of I. Yeah, this makes sense. After that the value change is minus 1. Yeah, if there is a first operation, then I need to find the if count of this index, count of m dot count of index, this index, if equal to greater than 0. If this index is present in map, then uh, sum will be the, I'm gonna say what is the previous value of m of this index, what is the value at this index, and new value will be this one, or value sum changed will be sum is equal to what is the new value, that is the val minus previous. So that's how our sum will be changed. And I'm gonna update m of index is equal to, that is the value, I'm gonna update this. Okay, now if the value is not present, if it is not present, then what I need to do, i simply I simply take the value changed, the changed value, then I will say that if this index is not present, then the value of this one will be changed, and the, sorry, this is the value minus changed. Okay, and I'm just putting the sum index value will be well. Okay, I'm gonna make it public by the outside this, so I don't have to apply this again and again. Hmm. This is clear. Now when I place a first operation, then I'm gonna make my map clear and change the value to x, and after each operation I'm just printing my value of sum. Yeah, here we go. I think it will gonna work. Let's check it out. 1990 20 11 11, what is the value, 1950. Okay. Oh, wait a minute. If this is the second operation, then sum will gonna change to n into x. Oh, my bad. I forgot to change the sum here. Yeah, 1950, 51, 42, and 5 exactly. Okay. Yeah. If I think so, that will gonna, this will be good. Let's see. Oh, yeah, it is accepted. This is the second problem. A, B, C short. You are given three arrays A, B, and C initially. Array A consists of elements, B and C are empty. Okay. You are performing the following algorithm that consists of two steps. Step one, while A is not empty, you can take the last element from A and move it in the middle of array B. If B currently has odd elements, you can one choose place the element from A to left or right or middle element of B. Okay. So first of all, I need to take the last element from A and I need to move it to the mid of B. And now if B has an odd element, you can choose if B you can choose place place the element from A to left or to right or middle of B. As a result, A becomes empty and B consists of n elements. Okay. Place the element from A to left or to right of middle element of B. Okay. I got it. Okay. Okay. While B is non-empty, you can take the middle element from B and move it to the end of array C. If B is currently has even elements, now if B currently has even elements, you can choose which of two middle elements to take. As a result, B becomes empty and C now consists of elements. You take the middle element from B and move it to the end of C. If B currently has, okay, if B currently has even elements, you can choose which two middle elements. Refer to the note section for the C. You can make array sorted in non-decreasing order. Can you make? Okay. So first of all, I have this array A, B, and C. Okay. Now, when I have this array, so I need to take the last element, that is 3, and put into the B. Then I need to take the last element. And now if it is uh, odd number of element, now it is a odd element, so I'm gonna choose where I need to put at the right or left of the middle element. Okay. And if it is even, then I need to put it to the left element. Okay. In the second step, what I need to do, I need to put I need to take any middle element, the middle element from B. Okay. The middle element, that will be n by 2, 4 by 2 equal to, okay, and putting this here. Then I'm gonna take the third, then put it behind. Okay. So basically what we are given an array A, like A1, A2, A3, A4, and A5 array are given. Then I need to make array B, and then from B I need to make array C, and I need to find that it is sorted or not, in non-decreasing order. First of all, what I'm gonna take, I'm just taking the last element and putting in the middle. Now here is the A5. If okay, I'm just putting here. Now if we have odd number of element, then I can put the A4 here or here. Okay. So the if array look like A4 comma A5 or A5 comma A4. After that, I need to put A3 in between. Then this will be look something like A4, A3, A5, or A5. Then this is similarly odd. Then I need to put A2 here. Then it will should look like A4, A2, A3, A5, and then A1. Okay. So you can say that, and if there is a A6 element is also there, I can put it anywhere. So it will be A4, A2, A6, A1, A3, A5. So here you can notice that they will just making a pair. So you can say I can change A4 and A5, their position I can change, because if I take this array, then it the values of A4 and A5 will be changed. Like if I'm taking the yeah, this array, then A5 will be in front and A4 in the last. Similarly, you can change the value of A2 and A3 and A1 and A6. Okay. A1 and A sorry 5 and 6. So if okay, this will creating a confusion. Okay, this will be good. So you can see that I can change the position of A4, A5, then A2, A3, and similarly A1. Okay. Then what I need to do, then now I can understand, like I can make B accordingly. So I can understand, like I can change then A4 or A5, then last two element, from the last two element, the first one of the element will become in the front and one of the element will become in this last. Similarly, from after that, another two elements that will become, one will come from the second last and one will come from second first in the second position. That's it. Okay. Similarly, I can make the array accordingly. Now in the C, what I'm doing, um, in this type of problem, you once go through the problem by taking the A1, A2, A3, then you will easily understand what is going on and what is happening. Then it will be really easy. In the this what I'm going to take. Take the middle element from B and move it to the end of C. Okay, take the middle element. I can choose, like, if there is, so I'm gonna take A1 and put at end, that is A1. Now it is empty, I'm putting here. After that, uh, it is should look like, oh sorry, it should look like something like this. Then I can take any element from these two, A2, A3, if the length is odd, and I'm making A2, then it will be A3, or I'm just changing A2, A3. Then if A5, A6, then will be A5 and A6. I'm changing this. So you can see that I can change any two element, like only two elements from, if I'm just A4, A5, sorry. So if I am having at the end A2, A3, A4, A5, A6, something like that, at what I'm the, if I'm just go through all the steps, making the B and then C, then what I can do at the end, I can just interchange the values of A2 and A3, just swapping the values of A1 and A3. Okay, then two elements, that's it. So what I'm gonna do, I'm just swapping the elements. If I found that by the swapping I can make them non-decreasing, then it will be good, otherwise it is not. Okay, just I'm just taking the values. Okay. uh, yeah, here we go. So what we have, int n, scene, and then we have vector of int a of n. I'm just taking for int I of n, scene a of I. I'm just starting from the back. Int I is equal to n minus 1 and I is equal to 0, I minus minus. Sorry, I don't minus minus, I minus 2. Okay. If I is equal to 0, that means there is only one element is present. I'm gonna make it continue. Else there are two element. So if a of I and a of I minus 1, then I will need to make it increasing or non-decreasing. So a of I value must be greater than a of I minus 1. That's it. If a of I is greater, I'm gonna swap a of I and a of I minus 1. So yeah, I think so. Yeah, that's gonna solve my problem. And I'm making b is equal to a. So I'm just making a shorting, short b dot begin, just shorting the b element. And if by doing the operation, if I'm able to make b is equal to a, then I'm 100% sure it is shorted and I can make able to do that. If I'm not, then I'll say I can't. Okay. Okay. I need to take the test cases. Yes, no, yes. I think so, yeah. So this is the third problem. Dolce Vita. Turbulent times are coming, so you decided to buy sugar in advance. There are any shop around the Shell sugar. Okay, that's Shell sugar. The ice shop sell one pack of sugar for A of coin, but only one pack to one customer each day. So in order to buy several pack, you need to visit several shops. Okay, another problem is that price are increasing each day. During the first day, the cost is AI. During the second day, it will be I plus 1. During the third day, it will be minus AI plus 2. And so on for each shop. Okay. On the contrary, your everyday budget is only X coin. In other words, each day you go and buy as many packs as possible with total cost not exceeding X. Note that if you don't spend some amount of coin, you can't use these coin during the next days. Eventually, the cost for each pack will exceed F. You can't able to make buy single pack. So how many we able to buy uh, till that moment in total? Okay. Hmm. Hmm. I'm just giving what I'm giving. So what is happening? I'm making a of I, then I have a of I, then a of I plus on the second day. On the first day, I have a of I and something. So on the second day, it will be something like that: a of I plus one. Sorry, I need to what I need to do. Eventually, the cost for each pack will exceed X, and you not be able to buy even a single pack. So how many pack you will be able to buy till that moment in total? Okay, it will be AI plus 1. On third day, it will be minus AI plus 2. So you can see that this will be increasing for all of these, all of the elements, or all of the, you can say, uh, for all of the cell, all of the sugar pack. Okay, I need to print that is on the 11 day. Day 1 will be 212, is will be 233. Oh man, it will be not minus, sorry. And I'm saying I'm not able to do that actually. Okay, so what is given is that first of all I have a of I plus 1, then on the second day it will be a of I plus 2. So, okay, in third day it will be a of I plus 3, something like that. So I can, on the nth day, the it will be a of I plus n into n minus 1 by 2, the price. So I can gonna check, like, uh, first of all I'm gonna do what I'm gonna do, that I need to purchase the maximum number of packets. Okay, so I'm just starting with the maximum one. So what I'm gonna do, you can buy one pack here, you can buy two pack, so there will be 8, 2, 3, 4. So for I'm just sorting the array, then this is the minimum value of the cost, so I'm going to need to buy this. I'm gonna say like how many day I'm gonna buy this, I will able to buy this. So it will be a of, I'm by using the binary search, I'm gonna make it like how many days I need to buy it. I can make it to buy such that the value is less than equal to X. Then I'm coming to A2. Then I will see what is the money left. Let's say money left is X here. Let's say it is the X, then it will be Y here, and Y is equal to A of X minus A of I. So what I'm gonna see, for how many days the money I will able to buy this, and the money will also be look like, if there is n days, then the money we gonna left will be y minus n into n minus 1 by 2. Okay, and the price will be a of 2 plus n into n minus 1 by 2. Why it is so? Because actually it is n of a, sorry, it is n of a of I, because each day if I need to spend here the x on the first day x rupees, then on the x plus on the second day I need to spend x plus 1 rupees. Okay, so here will be y minus 1. Okay, so if it is a1 a2, then I on the first day spending a of 1, second day I am spending a of plus 1. If I have left on the first day y rupees, then on the second day the left will be y minus 1 rupees. On the third day it will be y minus 2. Then I need to check. So I'm just applying the binary search on each of the elements. Right? In how many days I can able to make this, and for how many days I will able to make this. That's it. So let's gonna code for this. Uh, Hey my reader, we have int n comma x. Need to make a vector of type int of a of n. For I of n, just take scene a short a dot begin and a dot end. Then for int a I is equal to 0, I less than n I plus plus. I need to make for how many days I will able to make this. So I'm just, let's say it will be long, then it will be more good. Up to yet, what is the up to yet? Up till how many? What is the amount I spend? Let's say it is 0. So money left here, we left with uh, what is the value I and how much I spent. That is up to. Okay. Now I need to apply a binary search. L is equal to 0, R is equal to. So first of all, I need to check if A of I is greater than left, then I can able to make it. So I need to break it. Okay. Then up to how many I can go? I can go up to 8, 9 plus 10, let's say. Okay. So while R is greater than equal to L, I'm gonna mid is equal to R minus L plus L by 2. So why making this? Because it you can also write something like that. Okay. Hmm. Let's say it is long, then it will be fine. So I need to find. Okay. So you can see that if I have A1, A2, A3. So I spend money A1 plus 1 here, then I spent A2 plus 1. On the third day it will be A1 plus 1, it will be A2 plus 2, it will be. So what is the money left for A3? It will be is equal to let's say y is equal to x minus A1 plus A2. For this one the money left is equal to y minus 2 into 1 y minus 2 into 2. Okay. So this will be how many order it is using the I value. This is the I value. So it will be I into n minus 1 by 2 for the general I. It will be something like that. Okay. So what is the money required here? So money required is equal to A of I into mid and plus each day there is a increasing price and it will be mid minus 1 by 2. And how many money I have? Okay, this is the required money actually. And so how many my money will go next, will gonna decrease. So if I'm at particular I, so my on this I, actually I don't need to decrease this one actually. Okay. So first of all I'm gonna see I'm having I just take this A of I, then up to how many days I can make it. Then I'm searching for I plus 1 2. then how many days I will gonna make it. Then I'm also separating the x here also. Okay, so the money left is equal to that much. Then I'm just checking. So okay, yeah, so I don't need to check for this all of these things. I'm just checking how many money left. I'm just so, but there is a problem. What problem? So if I am a A1, A2, and A3, if it is true, this is 4 and this is 5. Let's say, let's say I have money 10 coins. So I can purchase 2, 3, 4, and I can purchase 5. Let's say 15. I have 5 or 5, 10, 14. I have 15. Okay. But this is 3. But the price of this is 3. Okay. So instead of buying this 4, it is always optimal to buy this 3. Hmm? It is always be good to buy this one instead of buying 3. And let's say it is also 3. Then instead of buying this, it is always good to buy this one. Okay. Hmm. Yeah. So that's not the, I think, solution. We need to think something else. Hmm. Interesting question. So what we need to do? Hmm. I'm gonna make like hmm. Yeah, that's the thing. So what I'm gonna do, like let's say the difference between them is 1. So for one day I'm gonna buy, like what is the difference, maybe like it is 4, so difference is 2. For 2 days I'm gonna buy these sugars, these packets. So the money will be the days 2 into 2 plus 1 by 2, 2 into 2 minus 1 by 2. Okay, so now the price of AI will be equal to this one, A2. Yeah, here we go, that will be a good. Yeah. So what I'm going to do, what I'm making the all the packet price same. So if I am having the price, let's say this is A1, A2, A3, A4, and A5. So first of all, let's say this having price 3, this is 5, this is 8, and this is 8, 8, 2. So what I'm gonna do, I will gonna see like how many, the difference is 3. So for 3 days I'm buying this one. So on the first day I'm buying 3, then 2, then 4. I'm 100% sure that on this day the price is same, so I'm not buying this. Now the price is same, 5, 5. Okay, so for the 3 day, what is the value? Just I'm just taking the 3 packs only. Now the value is 5, the value 5, then the value of 8, and the last value is 5. So the difference is 3. Now I will buy 3 packets, like 5, 6, 7, 5, 6, 7 from each of the two. They're like 5, 6, and 7. That's it. I'm gonna see how many packet I can buy. Okay. Yeah. Then the value will become 8, 8, and here also 8, 8, 8. Then I'm buying, first of all, I'm buying all of these 8s, one, one, one from all of the shop. Then this will be the one optimal solution. Yeah, I think so that this is the optimal solution. So I need to do that in this fashion. Okay. I'm just making the all of them equal. While it is lower, I'm just taking the sugar from this shop. When the price will become same for, but oh wait. Oh man, but the price is also increasing for this one. It is always optimal to buy from a one shop. Sorry. Yeah, now I got the actually what is going on. Actually, the price is increasing all day, I think so. Or it is while we are just it is increasing all day. Shit. So if this is 3, this is 4, 2, 3, 4, and it will be 2, it will be, let's say it is 5, then it is always optimal. But at this point, I have only X coin. I need to spend X coins. At this point, I have X minus 2 coins, and also coin is also increased. So here this point X minus 3. At some point, the coin will be my value of coin. Sorry. Yeah, that the first one solution is good. Here the value is the X minus 1, then X minus 2, X minus I. So will be the value will be X into n minus 1 by 2I on the nth day. The value of the X remaining is this, and I need to see if it is greater or less than n into n minus 1 by 2. Yeah, that's it. I need to only check this. The money on this day, on the middle day, I have, that is the left one, left minus mid into mid minus 1, mid into mid by 2 into I. This is the money I'm going left on the midday. Okay, and if this money is enough, sorry, the price will be this much. If this money is uh, this money, I have this money, if it is enough to buy this product, so I'm gonna say this is the price. This is the price of on the mid day will be, price will be this much. Price will be I into mid minus 1. Sorry, I into mid minus 1. The price on this day is this much. So we have an independent X for each day. So I'm just looking. So what I'm just looking is that, my bad. So what I'm just saying, I'm having price sum 2, 3, 5, 6. So here I just take X minus 1 rupees. Let's say I have minus 1 rupee. What price I take here? I just take here 2 price. The price of this one will be 2 plus 1. Here will be 2 plus 2. Here will be 2 plus 3. On this day, I just already subtracted y is equal to minus ai, that is x minus 2. Okay, now here what will be the money I have left? A of y minus 1, y minus 2, y minus 3. And on for the third product, the money will be left I minus 2i, y minus 2 1i, y minus 2i, y minus 3i. That's the money I have left. So it will be, oh, what is, it will be mid. If price is enough, then L will be, I need to say plus 1, else R is equal to mid minus 1. Yeah. So answer, what will be the answer is equal to 0. Answer will be R plus 1. Sorry for the R, is R. That is the result. Yeah, I think so. That will gonna work. And I need to increase up to also. Up to is equal to A of I. I need to output answer. Okay. Actually, I didn't read the problem very well. That's why I'm having the issue. 1001. 1001. Little bit difference is there. So what will I'm just making answer 0. I'm able to make up to LA's answer is equal to mid. What happened? Oh, answer. Ouch. I need to make it answer 1 because answer is already defined. 10 1. What is the problem going on here? Let me check out for ith one how many I can make. That is answer 1 for how many days I will able to make this. For the 0 I can make up to 7 days, and I can see up to 7 days I can 1 2 3 up to 7 days 100% correct for 2 days, but can't 3. So only 2 price for 2 days 100% true. 2 is only 1 days, 3 only 1 days, only 1 day, so it will be 100% correct. Then 7 plus 2, actually I can buy for 3 days. Second pack I can buy for 3 days actually. So you can buy 2 packs 4 and 3 for the 3 days. That's a problem. Okay, so what is going on? I need to see, like 7 minus, I have total money 7, then the up to will be 7 minus 0, 7 minus 1, A of I is 1, will be 6, money will be 6. On the second day money will be mid minus I, left minus first day. Actually, okay, it will be mid minus 1 into I. Because on the mid, on the first day it will be 0, on the mid day it will be mid minus 1. That's my program. That will be fine. It's work fine. Okay, this is accepted. So okay, so yeah, thank you. I'm just solving these 3 problems only. Okay, thank you.